Good day, everyone, and welcome to today's webinar, The Keys to Securing Industrial IoT Environments, hosted by IOT Solutions World Congress and the Industrial Internet Consortium. A special thank you to our sponsor for today's webinar, Generalitat de Catalunya, the Government of Catalonia Ministry for Digital Policy and Public Administration. Before we begin, I want to draw your attention to the chat feature on your dashboard. Please feel free to introduce yourselves to our speakers and fellow attendees. I've also included links that you can use to connect to the speakers on LinkedIn and Twitter. There is a download button on the top of your dashboard where you can download 2 PDF copies of today's presentation. Slides. We will be dedicating time to your questions today. If you have questions for our panel, please submit them by typing into the questions tab on your dashboard. The webinar will be available on demand at the conclusion of this session, and a link will be emailed to you. And now it is my pleasure to introduce to you today's speakers. Your host for today's discussion, Manuel Garcia, is Business Unit Director at OBE Spain. And Manuel is joined by Albert Vives, Corporate Security Manager at IDIADA. Manuel and Albert, welcome.
Thank you.
Thank you.
Thank you.
Okay. Well, good morning or good afternoon, depending on the time zone you are in. Let me please appreciate the support of the organization. Special thanks to both IoT Solutions World Congress and Industrial Internet Consortium. And also very, very special thanks to Generalitat de Catalunya for supporting this event. Let me make a brief introduction about who I am and especially the company I work with, which is OBE, a company which is basically specialized in the European market and also a strong presence in Latin America, especially in Mexico. A company with more than 6,000 employees, more than 400 million euros in revenue, and more than 20 years in experience, which is also trading in the Paris Stock Exchange, but where the biggest amount of shares, more than 56% of the shares, are owned by the management team. We have presence in the mainly financial sector, but also on security, public sector, utilities, telcos, and media. And these are the countries we are working in. We have also a very specific edge on having our features, skills, and knowledge certified by standard organizations like ISO. And especially on the cybersecurity side, with both ISO, IEC 2701 and the Carnegie Mellon's CERT Computer Emergency Response Team, so we can provide special services to our customers. What type of companies we work with? Here you can find a very wide explanation, depending on the vertical sectors and also depending on the countries. But there is a very extensive list of companies we work with. And once I've introduced a bit about the company, let me go into the details. First, because of Internet of Things and especially Industrial Internet of Things is a quite new name over the last 7 years. Let me make a brief introduction of the previous wave of doing things in a smart manner, which was the smart cities. We were working with within the smart cities arena for many years with the Barcelona municipality, where we began more or less by 2010. So we have a strong edge on knowing how to make a city smarter, and at that time, the main thing was about sensors, which is perhaps the mainstream over the last years for the industry also. So when we were able to know what the cities were willing to do about sensoring, we then were able to apply the same knowledge into the industry. So the challenges for cybersecurity is more or less the same as within the cities, is to connect the things that you have deployed. In the case of a city, it can be a garbage container or a parking sensor. In the case of the industry, it can be a valve, or it can be an engine, or it can be a robot. So it's how to connect these things to the networks, let's say the intranet, or publishing services to the internet with proper security, because each vendor has its own security protocols, if that is the case. Then how to assess the customer, how to reduce, how to mitigate the vulnerabilities that are inside every device, how to minimize the attack effect, how to provide resiliency. And also learn, because this is not a once in a lifetime process. It has to be an iterative process. So in this sense, what type of learnings can we provide? There is a myriad of situations out there. There are cyber criminals, people who take advantage of their knowledge to obtain money, or an advantage, a competitive advantage, or to steal industrial property. There are also competitors willing to provide their services or products instead of ours. And then there are, in many cases, insiders, people inside our organizations that are harming our interests. We have to be sure that we have the proper measures, of course. It doesn't have to be that simple. And especially over the last times, there is another edge which we have to take care of, which is COVID-19, which has provoked that many of our organizations are more and more exposed to the risks of the malware and people willing to harm organizations. So at the very beginning, by 2011, 2012, we were invited by the Generalitat de Catalunya to begin working in a program they were willing to develop, which was the industrial PhD program for the Generalitat de Catalunya. So we knew that that was let's say, a triple helix process where enterprises, public sector, and academia should join forces to move the research and development forward. So at that time, we applied to the plan, to the first edition, and we were able to obtain the proposal for one of our candidates to work in a project, which was the anomaly detection in smart city wireless sensor networks. This is a PhD thesis, which is published on this link below, where you can see how we were able to hack several sensor networks and how to apply different techniques to mitigate this. It was the beginning of how we could obtain knowledge in the sensors that are, in this case, was about cities, but that are currently applied in many industrial network situations. So that was the beginning, and then based on this, we were able to create what we call a white book made for the CECICAT, which is currently the Agency for Cybersecurity in Catalonia, which is also depending on the Generalitat de Catalunya, which is a book devoted to only industrial cybersecurity, because there are many publications around enterprise cybersecurity, personal cybersecurity, enterprises, general enterprises security, and also public sectors, but nothing written in, let's say, plain text for industrial enterprises, where most of the people, as you can see, there are blue-collar people, and typically cybersecurity was a matter of white-collar people. So we merge both knowledges to create this content, which is also available to any of you. Basically, and I guess this is the most important content that I can share with you about this book, is the sense that this has to be an iterative process with several stages. First of all is, of course, to evaluate the risks. In many industrial enterprises, the systems, especially industrial systems which were in place for, let's say, the last 10, 15, 20, perhaps 30 years, are not in the best state on the inventory. And basically because most of the systems are based on electronics, and in many cases, these are based in software. You don't have that inventory really updated. So evaluating the risk is the first step. With this inventory in place, we can analyze what type of vulnerabilities are already existing. If we were talking about a typical IT device, we could find the CVE list of any device and know what type of vulnerability apply to this asset. When we have all these vulnerabilities in place, we can apply a set of corrective measures, and afterwards we can then employ a procedure, an iterative procedure with policies also to create the necessary environment that can be repeatable. And finally, but not in least importance, is to train all collaborators, because we have to take something very very clear in mind, which is perhaps the weakest link on the chain is the people in the matter of cybersecurity. You can put as many firewalls, the data diodes, network segmentation, antivirus, and that stuff. But if at the end of the day the phishing emails arrives and someone clicks in, all the other processes on the kill chain must be very, very under control. So training people and having them really aware about what security means is absolutely mandatory, and then we can reapply many other iterations. If we mirror this to the quality process, which is also something which is transversal to the organizations, it's like a PDCA or a Deming cycle, where you can plan, deploy, check, and act, and repeat once every time. I don't know if there is any type of price like in quality for the security, but more or less this should be something in place in most of the industrial companies. So going into first place about how we discover, how we evaluate our assets, is using techniques and technologies that allow to absorb, typically in a passive manner, because we cannot inject traffic in most of the industrial networks because you can interfere with the industrial processes, and obtain something like this. How many assets do we have? How many programmable logical computers, which are very critical devices? And how many different vendors do we have in our network? And then, with this discovery in place, obtain something like this. my network architecture, both the IT and the OT side, with all the different layers, with the SCADAs, HMIs, MES, PLCs, and field devices. Then, once we have this list of assets, we can then map these against the most typical vulnerabilities databases. So we may know if we have a very medium, high, critical, low informative situations that require our attention. In this case, taking from one of our customers, we, for example, found a Stuxnet vulnerability present since, I think, 2010, where Stuxnet appeared, and that was already present in their network. So they could be that could be exploited and used against that enterprise. As you may see, every asset has information that can provide us what are the hints to mitigate these vulnerabilities, like this Rockwell PLC, which has a chassis with many cards in it, and we can know what are the communication devices, what are the protocols that are on the network present, and then how to address the possible vulnerabilities in it. Then we have to mitigate, we have to correct the situation. Here you can see most of the most typical corrective measures that should be taken into account, like, of course, monitoring the network in a continuous manner, patch and update the devices that need, not only IT devices need patching, but also industrial devices. Review configurations, because sometimes the own configuration allows to have backdoors and other ways to infiltrate and harm organization. Backup, you know that there is a constant risk with, for example, ransomware attacks, and perhaps unless you want to pay this ransom, you have to go back into several hours, minutes, days, or weeks for backup until you have a valid configuration that doesn't have this attack present. And we recommend at least to have a three-tier strategy. So you may have a local copy, a SAN or a network attached storage copy, and, for example, a cloud copy of all the configuration. So you may have a peace of mind that you will find a configuration valid for the backup to be restored. Also, of course, to segment and isolate according to the risk and value criteria. It's not the same to isolate, for example, the OT network on a critical infrastructure, let's say a nuclear power plant. So perhaps you have to spend a lot of euros or dollars in data diode. And for example, for a network which is not critical, you can have something easier. But this is also something that you have to take into account. What is the risk associated with the asset or with the service, which is the value that it provides to your company. Okay. Of course, you have to correlate data from different sources. There is typically the silo version where you monitor the HVAC, the electricity, the industrial process, and all that stuff. And you can correlate many information, so you can have a cross-check. Let's say you are, for example, having the example of the Stuxnet attack. You can see that the centrifugal machines are spinning at a certain speed, but this is under attack by some malware. If you have the information from the electric system and you see the consumption pattern, you can check if the baseline is according to the information that is gathered from the SCADA. So you can simply see if that matches or not. But as more and more skill shortages are, and in the situation that you can begin to employ these technologies, you will get the typical storm alarm. So you will be overwhelmed by the many alerts that are on your systems, and you can't deal with it in a human manner unless you have a very deep pocket and you hire a lot of people. So we recommend that you list your top 10 alerts, and then you automate and orchestrate these alerts. So you can have your people really dedicated to the important things and not to the very basic things, which don't allow you to see the important things. And finally, have a business continuity plan updated. Things happen, and you must have an alternative. Perhaps it's a disaster recovery property of the company. Perhaps it's outsourcing production to a third party. Perhaps it's, I don't know, going back to the backup. You must have this plan updated, and you have to check with your organization your ability to deploy this plan and to make proper exercises, which we will discuss on the training part. Going into more detail to some corrective measures that are highly recommendable is to build, as we said before, an umbrella system to monitor the different information silos. When you deploy this umbrella or manager of managers system, you will be able to check the different silos with a cross view. So you can then apply machine learning or artificial intelligence technologies to find where the problem is, to find the needle in the haystack. This is absolutely mandatory because things are happening at a very, very high pace. And unless you have a machine behind able to correlate information between the different silos, it will be very, very difficult, and you will find yourself in the situation where you have to, where you can, of course, always look back at the logs, but the harm is already happening. Of course, something which is very useful also, as we mentioned, is to create baselines, to create behavior patterns, not only for the personnel, which is very typical, is to know what people is doing and what is their typical behavior, but this is also necessary for the assets. If you have an execution of a certain program to make a specific piece of material, you can create a model, a mathematical model for how this works inside your production, and know what is the consumption, what is the timing, which are the cycle, and this is a model that it should be happening always for this type of material. So once you have this created along a mathematical pattern, you are predictable with your behavior. If something moves out of it, there is, for example, an outlier or deviation. Perhaps it's a matter of maintenance because the systems need some operations, but perhaps there is an attack. So that's something you have to take into account. Of course, detecting is important, but responding is mandatory to do it as soon as it may happen. Imagine a malware, a virus attacking a workstation. If you don't act properly, it can spread around your organization. So having, for example, orchestration systems that have, let's say, a playbook, a sequential program to execute, you can, let's say, for example, once you detect a virus on a workstation, you can notify the administrator. You can move from the VLAN of production to testing VLANs where there is no access to the rest of the network or intranet, and the problem is already isolated, so it cannot harm. You can go there, make some manual actuations, and the problem should be over without too much damage. We are going then to the policies and procedures. Some recommendations which are very necessary is to attach to standards. There are some standards like ISA 62443 or the same ISO 2701 or the COVID standard that are very applicable to the industry. Frameworks like the NIST framework, which have this figure about how to identify, protect, detect, respond, and recover, which is pretty similar to the framework that I already presented you. And of course, join communities, because we are not alone. We are in a very wide and deep world, and staying connected to these communities helps a lot in identifying what is happening, not only in your company, but what is happening around the world, and be aware about what may happen to me before it happens. So in this sense, I guess that Carnegie Mellon's CERT and the first organization are entities that have to be followed, and if possible, belong and participate. And of course, last but not least, training. As I said, helping people to not only to do their work better, but to have very good awareness about cybersecurity is to help them to know what are the risks out there. So simulate and play is vital. Many organizations make these awareness sessions where you can also make a role play, where people plays in a non-harmful environment, and then you can see what are the results, and you can look at how they improve in their skills. And in case that there is a doubt, nothing happens, because the environment surely is isolated. Of course, providing support, having specialized teams that are not only thinking about how to solve the problems, but also have a first response to people asking, should I look at this email? Should I open this attachment? Or should I send it to the spam folder? Is quite useful having someone available. And of course, deploy specific awareness programs. We are not self-training in many occasions. So having these awareness programs in place in companies is quite useful. In some cases also, it's a matter of the same industry, like the automotive or the chemical industry, that have specific programs, so you can your company can attach to it. Some exercises can be as simple as this, to avoid having an attack like this Ukrainian power company. Just simply click on a phishing email, deployed malware which attacked the SCADAs, and you could see this phantom mouse moving around and killing the breakers, the 110 kilovolt breakers that shut down, I guess, at 500,000 people's power in Ukraine a couple of years ago. Or, for example, how you can help to avoid your company have your data exfiltrated, how to avoid your company's intellectual property sent to some websites that are selling this by a big amount of bitcoins, or how innocent can be a pen drive, but how much damage it can create to your company. Or how do you publish yourself in the networks, in the social networks? If I'm saying I'm the responsible for a certain activity, I may be a target for some cyber criminals. So may happen something like what could have happened in the Tesla factory in Nevada some weeks ago, where some people were trying to offer a bribe to a worker, just to propagate malware inside the factory. So it's also about us. It's also about the people that work for the corporations that can help avoid our enterprises to be under attack. And at the end of the day, it's like most of the programs that happen in the companies, the projects are based typically in 3 pillars, which is technology, processes, and people. And all of them are very important. But I would like to highlight the people side, because even that I am a technology guy, I think that people in this case are the most important element that we have to take care of, and that can make the difference between what can happen and what happened in most of the corporations in terms of how we can protect our industrial companies by eliminating most of the risks with cybersecurity. And that's all from my side. Thanks a lot for your interest. And now, Albert, the floor is yours. Thank you.
Thank you, Manel, for your presentation, and thanks to everyone who has joined to this webinar. First of all, my presentation. One second. I don't know if I have the presentation right now. Okay, see, yes. So first of all, present myself. So I held the corporate security role at IDIADA, plus IDIADA, for almost 3 years, and I have the responsibility for physical and cybersecurity. So my experience is in information security in several companies in the field of information security for more than 10 years. And during these years, I was focusing mainly in information security and business continuity. So I think that there are these 2 topics are a good starting point to address security in the industrial environment. For instance, my consideration regarding this industrial cybersecurity strategy is related to these 2 different initiatives. The one arising from the application for the application of cybersecurity because the convergence of OT and IT, and others that belongs more to continuity is the understanding of industrial process and their elements, depending on such as information systems, networks, assets, providers, or specialized people. So this is, I think, is the basis of the action plan that we are developing at IDIADA, and this is my personal approach of this topic regarding the keys of securing industrial IoT. So my presentation is divided into 2 main blocks: the presentation of the company and the services. Then my personal analysis regarding IoT technology, and how finally we cover this gap with an action plan that we develop internally. So first of all, I want to introduce you what A Plus IDIADA is and what we do. So A Plus IDIADA is a global partner to the automotive industry with over 30 years experience supporting products, development activities by providing design, engineering, testing, and homologation services. The company has more than 2,500 professionals and has an international network of different branch offices in more than 24 countries. And in fact, the international expansion of IDIADA was the result of being close to manufacturers from all over the world. So this is a start a few more or less 10 years ago, and this was the main reason to the international expansion. Okay, IDIADA starts as an institute for applied automotive research in the University of Catalonia in engineering school, and in 1990 becomes an independent company from belonging 100% of the regional government of Catalonia. In 1999, IDIADA starts to operate under an exclusive contract of 351 hectares technology center near Barcelona in Tarragona, and is owned actually by 80% of A+ and 20% of the government of Catalonia. So around 10 years ago, the first step towards international expansion began in South Korea, followed by Germany, France, Italy, and we have approximately the half of the workforce in Spain, and the other half distributed by the international business units around the world. IDIADA provides several services to our clients, but they can be summarized in these 4 blocks: engineering, homologation, proving ground testing, and design testing facilities. IDIADA is specialized in the development of design and testing of all the functionalities of the vehicle through its laboratories, and its engineers and experience of a lead company in this sector. So we have different labs, from passive safety to active safety, vibration and noise analysis, engine analysis and powertrain, as well as emission, comfort, and the durability of the components of the car. So we have and we test several parts of the vehicle: body, closures, trims, chassis, and electronics. So if the value of the value chain that IDIADA provides could include all phases: design, validation, and approval, and of the product, of the automotive product. So from the creation of the concept, the design, through advanced tools from styling, feasibility, package, and surfacing, to the design of the prototype with advanced CAD tools, and at the end, the simulation of this product design, and to test the final product, mechanical or make the technological validation and homologation. So and to make all these different parts of the chain of the automotive sector, we have a team of different engineers and technicians who are divided more or less at 50% of their function into these 2 blocks: concept and design, 50% of the workforce, and test and validation, the other 50%. Okay, the first block of the engineering provides the design and the concept part. So this is the first phase where a new prototype is developed, or a new prototype, the interior car or a part of the car, and sometimes need to be tested for modification in the manufacturer's chain production. So this is the one of the most confidential departments, as they may be developing new vehicle designs, and maybe this vehicle design is not in production, so it's a prototype phase. So this team is in a project office with access restriction and with a very strict security measures, physical security measures, and also cybersecurity measures also. So another group of services are those related to passive safety. So this is a crash lab where the structure of the vehicle is analyzed, the protection of restraint systems, the protection of the occupants, and in many cases is used for the accident construction. There is several tests. One of the tests is the crash testing according to legal standards. A crash, for example, European Union regulations. A crash testing according to consumer programs like Euro NCAP. And another types of crash testing like rollover, misuse testing, and also we test some road infrastructure testing for example, for the motorcycle injuring for motorcycle or for heavy vehicles. So we test also road infrastructure. This in the HQ labs in Tarragona, we conduct around 25 or 30 crash tests each week. And the crash process has a complex automation because you have to calibrate, make sensorization in the different elements or the dummies. So each crash test it requires 2, 3, or 4 hours per vehicle. Okay, another lab are related to active safety, the braking system, intelligent transmissions systems, damping, and elements that allow to have control in adverse situation. The analysis of the powertrain is another lab. We test engine, we test different types of fuels, emissions, and we test the vehicle in different climatic chambers. The powertrain laboratory is designed to be able to evaluate vehicles in production, but we also study new formulas as a gas, electric vehicle, hydrogen, or different fuels bands. We also have a semi-anechoic camera where we analyze the internal and external noise of the vehicle and the vibrations. There are some brands of high-end vehicles that require many specific tests of this type. So this is very used to have this test in some brands. Another engineering is to the comfort of the vehicle in a different situation, like thermal conditions or thermal high conditions or thermal cold conditions. So we review the comfort of the different occupants here in these labs, and also the reliability of the vehicle. So it's one important part that we also analyze. We have a team that is especially specialized on different type of roads, on driving on different types of roads, and in reproducing the wear of elements such wheels, tires, damping. A few hours of driving on certain test tracks that we have can mean wear and tear compared to thousands of kilometers in real driving. So this is important test that we have there. electronic systems of the vehicle that also tested and designed at customer request, and it's a part of the intelligence of the vehicle. So it's important, this part. There are different sub areas here. Dealing with the autonomous vehicle, the connected vehicle, electronic architecture, and electronic design and reliability. An important part of this area is responding to the need to protect vehicles from cyber attacks. So new ways to hack vehicles have been discovered. That's clear. And to minimize this impact of this problem, it is important to protect vehicles at all levels, having this a strong impact on the implementation of the hardware and software of the car. So we have several tools here to combine various hardware tools, analyze the connectivity vectors of the car, and how the car affects the functionality, the security or the privacy of the car of the user in the event of the cyber attack. So this is one of the priority investigations that we are doing this currently. Smart mobility. This is IDIADA participates in the development of projects related to ETS transport and mobility. ETS is the integration of information and communications technology with transport infrastructure, vehicles, and users. So by sharing vital information, ETS allow people to get more from the transport networks in the greater safety and with less impact. So we are coordinating the C-Mobile project, which aims to demonstrate ETS solutions in real life conditions across Europe, based on a common architecture. These solutions are provided to the users through an app, which integrates services such as parking availability, roadworks, hazard warnings, changes in speed limits, approaching emergency vehicles, and another of warnings that is information, important information for the user. Okay. Homologation is another division that provides worldwide homologation services for the automotive industry. IDIADA is able to provide the list of mandatory standards and the standards that is required for each market. So it's 1 second, please. So, and this necessary report certificate. This department could provide many services to different vehicles, like buses, motorcycles, etc. Another, the last department, and is, but not least, is the proving ground. So we currently manage 2 proving grounds. Both are independent proving grounds. So we offer support combined with confidential workshops. And currently we have 15 tracks where you can test for different purposes: high speed, external noise, dynamic platform, off-road, wet handling, and autonomous driving. So due to the experience of the management of test tracks, we have created a business unit dedicated to make assessments to other third parties to build test tracks and using our know-how. So this is the presentation. We are moving now to the OT strategy that IDIADA. There are multiple elements in IDIADA industrial environment, but we don't have a production line such a vehicle manufacturing factory. So IDIADA has different laboratories that can be worked in combination way, but also independently of each other. So in our case, the situation makes that the threats or industrial risks are quite isolated. So obviously, if a sabotage or accidental break of some industrial element will have economic consequences and impact, but we have a risk segmented by the nature of the business, the structure in services, departments, and labs. Of course, all the labs and the information and of the data acquisition system that generate these tests have to be processed and managed through dedicated software and hardware. So, but and here we have hardware and software like of the industrial systems like SCADA, DCS, PLCs. So we have industrial elements like another industrial company. The information generated in the test in IDIADA must be controlled correctly because, of course, there is different labs and are isolated from other labs, but the information from the industrial system or the data acquisition has to be garnered into recording system, and there have to be interpreted for a specialist and the engineer has to understand all the information and to make reports. So this is a point of connection between these labs, this information that goes through different labs. And the confidentiality of the information is the most important thing for us because in many cases the test corresponds to the vehicles prototypes that are not some prototypes that are not in production. So it could be prototypes that are in the design phase. Okay. So industrial OT security challenges. Moving to the OT environments face several changes around. These challenges are not new. These challenges are old, but there is a high risk environment because a lack of risk mitigation and remediation with limited patching, a general lack of understanding of cybersecurity threats, and the probability and the impact on the potential impact is not understood and in some of the systems. So there is limited skills in the OT teams. So there is a gap here in that contributes a security vulnerability, and we have the data protection compliance that the government regulation can continue grow as cyberattacks increase. So we have to lead with this operation changes. No, so the first step that we have is low risk mitigation, limited access visibility, and high impact environments. So we have to try to resolve these 3 points. It is difficult to talk about the evolutions in industrial transformation and without mentioning this convergence between IT and OT. So operation technology monitors and manage industrial process and the equipment, and the mission is centered on the automation of these machines and processes, and it has a strong focus on availability with emphasis in integrity and confidentiality also, no? And IT is centered on the business operations, and it has a strong focus on confidentiality. So this is 2 different worlds that in this convergence becomes produce two things, no? IT threats are emerging as a new concept, and OT systems replace these tools and adopt another IT approach and operational practices and protocols. So this is important to understand. This IT and OT convergence is a reality. So and everything digital and connected with the benefits and the risks. And this convergence is not just about technology, but also about teams and ways of working. And the IT approach introduced these new threats in the OT environments. So what is the situation now in cybersecurity? So historically, several vulnerabilities have been known associated with both the hardware and the software of the industrial environment. So these vulnerabilities they were assumed because there was a little probability that this wall that they will be exploited because this wall was isolated. So the industrial systems were not connected. No, but in industry 4.0, this changed. So more and more industrial control devices use in IT, standard interfaces, operating systems like Windows or Linux, and the reason is because IT systems are easy to use and you can extend functionality and are cheaper. So these benefits are also acquire the problems for and the risk rates regarding IT. So we are talking about loss of system availability, increased number of malicious code attacks, more exposed to cybercrime, cyber espionage, and cyber terrorism. So it's possible loss of reputation. So for this reason, it's important to have a good cybersecurity strategy in the IoT environment with a focus on monitoring and responding to incidents. And the training through specialized companies or an effective cybersecurity program for the entire company now with the OT team included. So it was the difference, I think, from before.
Albert, I'd like to interrupt just because we have 2 minutes left. So I'm hoping that you can just do a quick wrap up. Okay.
So a good IT security program starts with this strategy. This is the strategy that includes IT and OT convergence and security priorities. You must understand the challenges you face before you can secure your OT environment. So the plan that we have developed in IDIADA consists in 3 main points: knowledge of the IT environment and its main critical dependencies, the assessment of new risk, and the application of technical measures to reduce the exposure. So to the first step, we are going to see very faster these 3 points. So the first step is to managing the process approach. So if every security framework requires identify and classifying hardware as a prerequisite. So one of the tasks that we have developed is to carry out an impact analysis like the traditional use in continuity with each department to obtain a snapshot of the devices, the operation carried out, the connectivity, and the support. So we also identified the OT team to integrate this team into cybersecurity training and different awareness initiatives in an appointment and appointed to an expert delegate into this OT environment who will be responsible for ensuring the security requirements are met in the production environment. The second point is the risk approach. or the risk understanding. So develop a security strategy to identify the risk, your risk and your risk tolerance. Security risk and compliance assessment to determine your level of compliance with frameworks or regulation. Security vulnerability assessment to identify vulnerabilities and develop a mitigation plan. And a good governance of the cybersecurity plan and a good cybersecurity incident to manage any event that you can have. And the last point is finally based on the information collected and the associated risk, and execute a different block of technical measures structured in these several points. Physical security. This is regarding control of the key elements of the infrastructure. So one solution of this is maybe an access system or identity and access management solution. Device management. A solution for this point maybe is different multiple sensors that monitor the industrial environment and are available from different manufacturers. Segmentation of networks, firewall, VLANs, and network diodes that could be a great solution for this. And regarding network architecture, maybe a intrusion prevention and identification of technology. And the default security, you must to know that the security functionalities, the data, and this could be a solution. Maybe use some software to encryption or to secure endpoints. And the last, monitor events. A good CM service or CM platform to manage the network security services and logs. So the thing is to go through this low risk mitigation to understand your risk, this limited visibility extended, and the high impact environment to mitigate it. As a conclusion, the protection of industrial systems has different complexities and of various reasons, the old risk and the new risk. IoT technologies are transforming the world, so in the coming years are increasing, and the risk is a challenge of all the companies. And we believe that the security manager or security officer is the performance of this function between IT and OT and OT, because these 3 points, understanding, could understand the business, is expert in cybersecurity, IoT, and a better risk management could be a good points to start with this with IoT securitization. Okay, so
thank you so much. I just want to thank everyone for joining us today, and Manuel, I just wanted to see if you had any final words to conclude this webinar. There were several questions that were asked, and I will email those questions to the speakers, and I will send them out to the person that asked the question, since we ran out of time today.
Okay, final words. I appreciate a lot the possibility to participate in this event. I would share with all of you hours, and if we could meet in person, we could have some coffees, beers, or tonic waters, and have long conversations. But I know that this is not feasible right now. I hope that we can do it in the near future. And the only thing I can tell you is take care of the personnel that works with you. help them to understand better the cybersecurity. You have a myriad of providers, manufacturers, and systems integrators, and very, very qualified personnel out there to help in your cybersecurity strategies. And especially all of you, take care, and hope that this pandemic is ending very, very quickly. Thanks a lot.
Thank you so much for joining us, and thanks again to Generalitat de Catalunya, the Government of Catalonia Ministry for Digital Policy and Public Administration. Please feel free to reach out to all of our speakers on LinkedIn or Twitter if you have any additional questions. Thank you and stay well.
Same for you. Thanks.
Thank you. Thank you.